All right, happy Thursday. I can't believe we're at the end of week 8. That's crazy. This term has flown by. So we are finishing up today with our confidence intervals. So we're going to be looking at mean today. Going to learn something brand new with a T distribution. It isn't super scary. It can be a little bit confusing, but I'm hoping I can get it explained to you well enough. So we're going to work on T distributions, and we're going to learn how to construct a confidence interval for mean to estimate the population mean. Then we're also going to be able to find the sample size when we're looking for confidence intervals with mean. So the same type of stuff that we did with proportions on Tuesday, we're going to be doing that with mean today. So it's the same. So confidence intervals are going to have the same meaning. We're just going to be using mean instead of proportions. Then we're also going to go over lab 5. Lab 5 is actually pretty quick. It's a pretty quick lab because you can just use your continuous data from the first lab, or you're always welcome to grab some of your data from your final project. I've had a few people do that just because they want to see what happens and they want to play with it a little bit. You can either grab final project data or you can grab from the first lab that continuous data. So either one of those is fine. We'll go over that at the end. And that's the last lab. So um, the data that you turned in for the project, that was part of your lab grade. I put that in the lab grades. So that's in there and that's part of that grade. The final project at the very end, the points are going to be the 60 points for the written report, the 40 points for the PowerPoint, and then you get an extra 9 points for your comments. So you just comment on 3 of your uh, classmates' presentations, and that's an easy 9 points. And it hurts if you don't have that, but it's super easy just to look at a few PowerPoints and give some nice feedback. Besides, doesn't everybody want to see what their classmates are doing? And I know that when took this class, I wanted to see what everybody else's projects look like because I'm sure we're all curious. So that's today. We're gonna get through this, and then you can enjoy the beautiful sunshine. I actually took my last period class outside today to watch a baseball game because I was like, it is too nice of a day to stay inside and do math. So we actually went outside and watched a baseball game. It was fun. So, all right, let us get going. So we already know what a point estimate is when we're dealing with proportions. So when we're dealing with means, our point estimate is just our X bar. So our sample mean, we just use that to estimate the population mean. So our X bar is the population mean. Those things are just the same. We just call them good. So that's all the point estimate is here. So if you have a population mean or you have a sample mean, we're just calling them equal at this point. So here we have 17 randomly selected pennies minted after 1982. I'm going to treat this as a simple random sample and I'm going to estimate the population mean. So all I'm going to do is I'm going to put these in my L1. Okay. And you probably remember from way back when, one variable statistics, one var stats. That's all I'm going to do. So I'm just putting these in my L1. You do not have to do that unless you want to. And you know me, the queen of typos. I'm so thankful for one variable statistics, that particular function. It saves so much time. I might have just put in the same things a couple times. Let's see if I'm, no, it looks good. Okay. So stat, calc, one var stats, and I just went into my L1. So my X bar here is just 2.46. So we're estimating, based on our sample, we're estimating that the population mean is probably somewhere around 2.46. At 2.46 grams, is it grams? Oh, it does say in grams. So we're just using our sample mean as our point estimate here. Just like we used our sample proportion for our point estimate, we're using it here as well. All right. So I just, oh, look, I didn't even have to do that. It's okay. So we usually round to one more. I should have done this then, round to one more than the raw data. So I should have gone to 2.464. Sorry about that. But same thing. So our estimate here, we are estimating that the population mean is probably somewhere around 2.464. That is our estimation. All right, so let me talk about t-distributions. So because we can't poll an entire population, and if we did, we wouldn't need a margin of error. Because we can't do that, we have to use our sample standard deviation. So we talked about this way back when we did sample standard deviations, that we remember sample standard deviations, we divided by n minus 1 because of the variability of in samples. We had to kind of err on the side of caution and make our standard deviation just a little bit bigger because of that variability. It's the same thing when we're constructing confidence intervals with our sample means. So because of that variability, we're going to use something called a t value instead of a z-score. T values look just like a z-score. We use them in many of the same ways, but what we're using with our t values, we use it is dependent on the sample size. And then also when we're finding our t-score, we use n minus 1 degrees of freedom. So I'm going to show you the t-table in a minute, but if I had a sample size of 16, I'm going to look at my t-table at 15. We go one down because of the variabilities of our sample. So the way we would calculate a t-value is you would take the data value, subtract the mean, then divide by our new standard deviation. And this is a t-score. This is a t-score, and we treat it just like a z-score. So you would still, if a t-score was super big for a data value, we would still say that it is an outlier. If it goes bigger than 2, we treat it just like a z-score, but it's a t-score instead. So we're going to show you uses for t-scores as we go, and you're going to use them in this unit. You're going to use them here in 9.2, and then we're also going to use them in 10.3. So t values are not going to go away, and there are some special calculator functions to use with t values. So I'm hoping as we go, this gets less confusing. All right. So as I said before, t values are really dependent on they're really dependent on our sample size. That makes a big difference. So this wants us to compute both the z-score and the t-score for each of these samples. I believe it's on my next screen. So here's the histogram when I do, okay, doesn't want me to, I'm not going to compute them, but I'm going to show you the histograms. All right. So here's the histogram for the z-score. This looks pretty normal. It actually looks pretty decent. It's got some weird stuff happening up here. It's got some weird things happening there. It doesn't look super skewed. It looks fairly normal. But let's look at our t value. So look at the t value. So notice that there's more happening in my tails for the t value, but the center of it looks a lot more, that was really ugly bell, but my center looks a lot more bell-shaped. Still ugly, I'm just leaving it. Looks a lot more bell-shaped than the z-score because we have the weird stuff happening up here with the z-score. That's not happening with the t-value. So for Z, it was symmetric and bell-shaped. Our center of distribution was at Z, or at 0. Almost all of the rectangles were between -3 and 3. It pretty much followed a standard normal distribution. So with T, it was also bell-shaped and symmetric. It had longer tails. So it probably does not follow the standard normal distribution because it had the longer tails and it is more spread out. But because we used a sample to find it instead of the population, it is more spread out there's more dispersion there. And most of the time, we don't know a population standard deviation, so we're going to use the t. You're not going to have to reiterate the difference between a t-score and a z-score. I'm not going to make you do that. But here is the information about a t-distribution. It's different for different degrees of freedom. So it's going to be degrees of freedom, think sample size. There's a little more to it than sample size, but you're nothing, unless you take some really advanced statistics classes, you don't need to get more specific than that. So degrees of freedom, think sample size. It is still centered about the mean, and it is symmetric. The area under the curve is 1, just like a z-score, z distribution. Half of it is to the right of 0, and half of it is to the left. It will approach but never equal 0 as we get super big and super small. This is the same thing as z. The area in the tails of a t-distribution is a little bit greater than that of a standard normal distribution. It's a little bit more because of a sample. So if we have larger sample sizes, our t-distribution is going to look more and more like a z-distribution, like the standard normal curve. It's going to look more like when we use the z-score. So remember back in chapter 9, we talked about the central limit theorem, where it becomes normal when our sample size is larger than 30. 30 is probably a little more than 30, but around 30 is when our t value and our t-score and our z-score become almost exactly the same thing. There's hardly any difference between them once you hit around 30. Now, this varies a little bit depending on how abnormal the distribution is. The more normal the distribution is, the closer it's going to get to normal as you get to 30. But 30 is just a great rule of thumb, and we're just going to call it 30. All right. So, so take a look here. So the bottom one, so the green here with the orange outline, when we have a sample size of 5, so notice my tails, they don't go down towards 0 quite as quickly, and the top of my bell is not as high. When we have a sample size of 15, it's getting closer to normal. So look at the tails here. The tails are looking a little bit better, and it is almost even. It is almost even with the blue up at the top. So it's getting closer. Now, if I would have given you a 30, it probably would line with it almost perfectly. So 30 is a really good number there. Now, I'm not going to ask you to determine, hey, do I use Z here or do I use T here? If we're dealing with mean, just use T values. I'm not going to have you try to make that decision. That's, as I said before, it's an advanced statistics class. Don't even worry about it. If you're using mean, we're going to use T values. If you're using proportion, we're going to use Z values. That's it. That's your distinction right there. Okay, so we use T values the same way that we use Z scores. So we're going to use our alpha or our alpha divided by 2 to find the spot right here, to find the area in this out there, and we're going to use that to help us find our T values. So it's just T sub alpha or T sub alpha divided by 2. That's it. So it's the same thing. It's just with T instead of Z. Same thing. All right. So we're going to find the T values. Going to do a little bit of time here. So we're going to find the T value such that the area under the T distribution to the right of the T value is 0.2, assuming 10 degrees of freedom. We're not going to do 10 minus 1 at this point. We're just going to learn how to use the t-table. So we're looking at an alpha of 0.2. So let's take a look. Oops, I need my z-score, my z-table. Let me see, do I have that here? Oh, I have it right here. Okay, so take a look. I'm using 10 degrees of freedom. So 10 degrees of freedom right here. And we're using one tail. So notice that this is just the tail to the right. So we're using one tail. So one tail right here, 0.2, and they intersect right here at 0.879. So my t value would be 0.879. Your table looks a little bit different, so I'm going to pop over to the table that we have. And my iPad's being weird. Okay. Okay, here's our table. If it's a two-tail, which we'll talk about that in chapter 10. I'm just because we're just finding z-score or t-scores right now. We're not dealing with degrees of freedom yet. We're gonna use 9 later. I just want you to read the table with 10 right now. So notice along the top, this is the table you have. It's the second page. So your first page is the Z table. The second page is the T table. The T table is a little different as it does areas in the right tail rather than the left. Because remember, Z scores are to the left, T scores are to the right. Don't ask me why. I don't know why they did this, but just in your knower, know this is true. Okay. So 0.2 is right here, and I'm going to go down to 10. So we're using 10 degrees of freedom and 0.2, and there's my number, 0.879. So it's just right there. Now, if I was looking at we have all these different ones. These are all the common ones. These are not, you're not going to get anything unusual in here, and I'm not going to give you any weird numbers. I will in a few minutes show you how you can find t-values on your calculator. It is nice. I love fancy schmancy calculators. I'll show you how to do that in a few minutes. Right now, learning how to use the t-table is a pretty good idea. And notice down here, so I'm going to scroll way down here. Once I hit 40, it starts jumping. Remember I said that it basically becomes z-scores after 30? So here at 40, then it jumps to 50 and then it jumps to 60. And it's because we're so close to z-scores that that they don't, I guess they don't feel that they need to be so precise. And look how small the difference is between 40 and 50 right here. It's 1.299 and 1.303. They're so close to each other. That's because we're basically at z-scores now. So look, see my z-score? So z-score with I'm just going to do 0.2. A z-score with 0.2 is 0.842. Look at how close we are to 0.842. It's so close. At 1,000, it's exactly the same. They become so close, it almost doesn't even matter. All right, so I'm going to go back to this screen, pop over here. All right. Whoa. So once again, we're going to find a t-score. The 0.05 is my alpha, and I'm assuming 15 degrees of freedom. Once again, I'm going to use 15. I'm not going to do 1 minus yet. So I'm going to go up here. What is it? 0.05. Okay. 0.05 is this column. We're doing 15 degrees of freedom. So go from 15 over to here, 1.753. So that is my t value. Questions about finding the t value on the t-table? All right. Okay. So when we are finding our confidence interval, we're basically doing the same thing that we do with the proportions. Well, first we need to make sure it came from a simple random sample. Our sample size has to be less than 5% of the population. And if it does not come from a population that is normally distributed, we want our sample size to be 30 or larger. And even if it isn't, if they tell you to do the math in My Open Math, just do it. Even if it's not, because I believe that there's one example in My Open Math. I believe there's an example in My Open Math that has a small sample size and it's not normally distributed, and we just kind of nod our head and just do the math anyway. All right. So the way that you find your margin of error is right here. So you're going to use T sub alpha divided by 2. So you'll take that alpha and divide it by 2, just like we did previously. And we're going to use the n minus 1 degrees of freedom. So as I said, if I had a sample size of 15, we'll use the 14 to get our T value. You're multiplying it by the new standard deviation. So this is that standard error or standard deviation. Because you're trying to find out, you're finding the edges of your confidence interval, how many standard deviations we can be from the mean and still be within the confidence interval. So it's the same concept, and it's technically the same math. It's just with that t-value instead of the proportion, and the standard deviation we use for mean instead of the proportion one. I'm going to do some math with this in a second here. All right, so let's start here. So this was the pennies that we had, and we're going to construct a 99% confidence interval. Oops. A 99% confidence interval about the population mean, weight in pennies. Our standard deviation, our sample standard deviation is 0.02, and our mean is 2.464. So the first thing I'm going to do is I'm going to find my T sub alpha divided by 2. So the way that I do this is I take 1 minus 1 minus 0.99. That's going to give me 0.01. Let's divide that by 2. 0.005. This is the alpha divided by 2 that I'm going to use for my t value. And we have a sample size. What was that? 17? 2, 4, 6, 8, 10, 12, 14, 16. We have 17 pennies. So I'm going to look at 16 on my table. So let's pop over there. So I'm at 0.005. So this is my column way over here, and I'm going down to 16. So this number right here, this that one, 15, 16, 2.921. So over to 0.005, down to 16, 2.921 is my t value that I'm going to be using. Pop back over. Okay. Now I need to find the standard deviation. So my sigma sub x bar is going to be my sample standard deviation divided by the square root of my sample size. Do not subtract 1 from your sample size here. That's only for t values. So my sample standard deviation is approximately 0.0049. Is that the right number? It is, because that's a really small number. So yeah. All right. So let's math this out. My margin of error. My margin of error, remember, is t sub alpha divided by 2 times my standard deviation. Okay, actually this is sigma sub x bar. So that would be 2.921 times 0.0049. This is going to give me my margin of error. So my margin of error is 0.014. Questions so far? I'm going to do the conclusion in a second, but I want to check to make sure I didn't lose anybody. Didn't leave anyone at the bus stop. Okay. So we have my confidence interval. Let me just write this. Is We are 99% sure that the population mean of weight of pennies is 2.464 plus or minus 0.014. Or we could say, let me math this out first. I just added the margin of error to 2.464, then I subtracted from 2.464. So I have 2.44. I'm going to go one more out because I don't want to round. Just do 2.45. Why not? I'm going to round to 2.45 and 2.48. So we're 99% sure that the population or the actual average weight of pennies is between 2.45 grams and 2.48 grams. Questions? Okay, let's take a look at the way that they mathed it out here. They did the same thing we did. I'm just showing you the nice typed one because they type it pretty. So our lower bound is the 2.45, upper bound is 2.478 grams. They use the word confident instead of sure. So they get more fancy than I do. There we go. Questions before I move on? Right. Okay. The website fueleconomy.gov allows drivers to report the miles per gallon of their vehicle. The data below shows the reported miles per gallon of Ford Focus automobiles for 16 different owners. This is going to be a sample. It's a simple random sample, and we're going to construct a 95% confidence interval. I'm going to use the fancy schmancy on my screen because after I do this, I'm going to show you the calculator function that we use for this. So I'm going to actually use this calculator on my screen here and put all those values in there. So do stat edit. I always have so much stuff in here. I'm going to put these values in here. And hope I don't make typos. Uh-oh. 38.9, 32. Okay, I think I got them all there. Give you a second to catch up. 2, 4, 6, 8, 10, 12, 14, 16. Okay, got 16 of them. Good. So I'm going to use one variable statistics to get my mean. Whoops, I don't want that. Okay. Use one variable statistics to get my mean and my sample standard deviation. I'm going to write these down. X bar equals 36.8 and my sample standard deviation 2.92. I just rounded to one more than our data set on both of those. All right, so here we are. So now what we need, we have a 95% confidence interval. So once again, 1 minus 0.95 equals 0.05. 0.05 divided by 2.025. This is the number that we're going to look for on our table. That's the number we're going to look at on our table. And we have 16 data values. So we're going to look at 15 on our table. Oops, I need to do that on my computer. Okay, so number 0.025 is right here. It's this column right here. Go down to 15. So my t value is 2.131. Okay, that's beautiful. So once again, 0.025 down to 15, 2.131. That's beautiful. Now, for standard deviation, we're doing sigma sub sigma sub x bar. Man, I can't even. Okay, 2.92 divided by the square root of 16. Put that in my calculator. 0.73. So as before, our margin of error is the t value times our sigma sub x bar. So I have 2.131 times 0.73. My margin of error, 1.56. Did I do any mathing wrong, or are we good so far? Y'all are usually pretty good at catching my math errors. So for our conclusion here, I'm going to write this up at the top because I'm running out of room. I'm going to, over here in red, I'm going to put my margin of error thing. So I've got either 36.8 plus or minus 1.56. Or I have 35.24, comma, 38.36. So we would say we are 95% confident that the population mean miles per gallon of a 2011 Ford Focus is between 35.24 and 38.36 miles per gallon. Or we could say we're 95% confident that the actual average miles per gallon for a 2011 Ford Focus is 36.8 miles per gallon plus or minus 1.56. So either way, my open math's going to jump back and forth on those. So questions before I show you the calculator functions. Okay. So this is the same thing right here, except for now, we're going to use t interval in our calculator. This is your calculator function. Yours is stuck. Come on, come on. I see it's stuck. You guys are probably seeing the same thing I do. I don't know why it moves so slow sometimes. Okay, so we're looking at t interval is what we're looking at. Give it a second and it'll circle it. I'm going to go over to my calculator and show you how this works. I'm looking at my other screen and I see you guys have a delay. As I'm assuming you have the same delay that I have. Okay, clear this out. So remember that I already have all of this list. I already have it in my list one. It's already there. So I'm going to go to stat and tests, and we're just going down to t interval, which is number 7. Number 7 is t interval. So let me go down there. and hit enter. So we have two different choices here. If I go over to data, if I click on data, it's going to fill in the information from list one. So our list is already in there, so it can collect everything it needs from list one. So that's a really nice thing about it giving us the data. We do have to put in the confidence interval, which is 95%, so that's already there. So we do have to put that in and then we calculate it. So once again, this gives me the mean. This gives me the population or this sample standard deviation. And this is my confidence interval. And we had 35.24 and 38.36. That's pretty darn close. It's just a rounding thing, but my open math's going to accept either one. And remember, if you need to find the margin of error, you would just take this top number and subtract the mean from it. And that's going to give you that margin of error. So let's say that they didn't give you a list of values. Instead, they gave you the mean and the sample standard deviation. So if that's the case, I'm going to go back there, go to T interval. If that's the case, I'm going to go to stats instead. When I'm at stats, it gives me the option to put those things in, and you're putting in the standard deviation that you're given. You're not putting in the new standard deviation. I'm going to just put 2.92 because that's what we have for our data. This rounding is what gave us the slightly off, and put 95% confidence level. So this is where you're putting in your own stuff rather than calculating it with list one. And there we go. So it's still slightly different, but I'm not sure which rounding caused that to happen. But that's okay. So now we have our confidence interval here as well. So it's the same thing. So either way, any questions on that?
Do you walk us through it one more time?
Yes. For which one? The one with the data or the one with the stats, or both of them? So if we have the data, you put it into L1. If you have the data, so we put it into list one and leave frequency at 1 and just put the confidence level in. It'll calculate all of the stuff that you need calculated. And it's lovely, lovely and beautiful. Then, if you don't have the data, if all you have is the mean and the sample standard deviation, go to stats and you just type in the information. So type in your X bar, type in your standard deviation, and this is the sample standard deviation. This is not the new standard deviation. It's not the standard error. And you type in the actual sample size, not n minus 1. Type in the actual sample size and the 95% confidence level and hit enter. And there you go. Is that good? Okay. So let's say you either don't want to use the t-table or they give you like a number that's not on there. For example, let's say that it gave me 43. 43 is not on here. Yes, I can estimate it. I can just take the two values between, like, for example, here, 47 and 50. I could say, okay, if it's 43, it's probably at 1.049. I could probably guess, and it would give me what I need. It'll probably give me an answer perfectly fine for my open math. Probably be absolutely okay. But your calculator can do so much for you. I think some of the older calculators don't have this function. So if it doesn't, I'm sorry. If you don't have it, some of them don't. But if you go to vars, that's not vars, second vars, remember we did inverse norm? We also have inverse t. Inverse t will give you your t value. So if I go in there, the area that we're putting in there will be your alpha divided by 2. So I'm going to use this question that we have right here. So it's 0.025. That's the alpha divided by 2 we just used. The degrees of freedom you are putting in here is n minus 1. because it doesn't know what you're dealing with. It's going to calculate based on however many degrees of freedom you put in there. So you're going to use n minus 1. So I'm going to put 15 in there. And I'm going to hit paste. And then bam. And it's going to give me a negative value, but that's absolutely okay. You just need to make sure you're using the positive. Same thing with the z-scores. Just make sure you're using the positive. And it's 2.131, just like we got, which is beautiful. So the inverse T is a great tool. Sometimes we're too lazy to look at the T table, or we misplace it, or we just don't want to deal with it. Inverse T is your friend. Any questions before I jump back into our lesson? To our PowerPoint, I mean? Okay. Bam. All right. So, sample size. So, we have a problem with sample size here, just like we did when we were dealing with proportions. So, once again, we just took this formula back here. We took this formula and I just solved for n. Okay, let me jump back. There we go. I took that formula right there and we just manipulated it and solved for n. So that's all we did here. And so, or this formula, I didn't even have to go anywhere. We took this whole thing right here and I just manipulated it, mathed it out, and solved for n. The problem is the t value is dependent on a sample size, but we don't have a sample size. Therefore, when you're looking for a sample size for the sampling distribution of mean, we're looking for the sample size, you need to just use the z-score. Because we don't have a t value, we're just going to use the z-score. So that's the only difference. It's the only thing we're doing different here. And so you just take the z-score, multiply it by your sample standard deviation, divide it by the margin of error you're looking for, and then square it. And as with proportions, you round up to the next highest number because the school bus problem that I was talking about. So let's jump over to a problem. So back to the pennies. So I want the estimated mean weight of the penny. I want it to be within 0.05 grams. I want that to be my margin of error. We want a 99% confidence. And I'm assuming that the standard deviation is 0.02. So we have to take either the population standard deviation or some other sample standard deviation, because obviously if we haven't taken a sample yet, we don't have a standard deviation. So there's going to be some other standard deviation out there that we drew from. Don't worry, they're going to provide it for you. You don't have to go looking for it or anything. They're going to give it for you, give it to you. They'll say, we're assuming this is the standard deviation. So remember, this is our formula. Z sub alpha divided by 2 times standard deviation divided by margin of error squared. So I'm going to go back to my T table or my Z table. So on my Z table, go back up here. Remember this? Remember our old friend? Hold on, scrolling. Remember our old friend right here, our critical values? 99% gives us 2.575. I'm writing it down before so 95% gives me 2.575. This is why I have a second screen up so I can pay attention if there's lag. My standard deviation, my S is 0.02. So let's write this out. Ooh, why did that suddenly get small? I don't know. So 2.575 times 0.02 divided by 0.005 grams squared. If you're good with your parentheses, you should be able to put this entire thing in your calculator. making sure I didn't typo. I got approximately 106.09. Can I get a confirmation there? So our sample size that we need a sample size of 107. Remember, we always round up. Thank you, Gwen. I appreciate it. So we need a sample size of 107 in order to get our margin of error of 0.005 grams with a 99% confidence. Bet you dollars to donuts this is printed on the next screen. Look at that. It is nice and pretty and printed on the next screen. There you go. That's beautiful. I feel like this formula is easier than the other one. The one for mean is easier than the one for proportion. The proportion just seems, I don't know, clunkier. I don't know why. All right. I would like you to try this one. What was my standard deviation on this one? Let me find it. I could probably get to that pretty easy. Just go to the t interval because it was already in there. Standard deviation was 2.917. Okay. So my standard deviation is 2.917. I will also go get you the Z score. 95% is 1.96. I'm confident that you can look at your thingamajiggy and find that. So go ahead and try it. I'm going to work quietly behind you. You got 131? Did I do something wrong? I see. It's quite possible I did something wrong. Looks, my numbers look correct. Oh, you did. Amy got it also. Gwen, look for typos in your calculator because you're only slightly off and maybe you rounded different or something. Because that's what I got, Amy. So I have 131 is would be my sample size for the cars in order to get our things. All right. So I have a kind of a summary. I have two summary slides at the end of this. I want to real quick see if there's any questions before we get to the summary slides. So I threw the summaries on the end because many people were getting confused at when you use which proportion stuff, what do the questions look like, and when to use which one. So I threw a couple of summary slides on here. So here's the difference between what we did Tuesday and what we did today. So what we would look for with the proportion is it's going to have the word proportion in it. The word proportion is going to be there. And we're going to use for our margin of error is going to be z sub alpha divided by 2 times the square root of p hat times 1 minus p hat divided by n. So this is our margin of error here. Oh, you rounded to 2.92. So isn't it weird what a big difference that something so small like that makes? Okay, so today you're going to see the word mean. The word mean is going to be in there. And so your margin of error for today is going to be the t sub alpha divided by 2 times S divided by the square root of n. So important that your t, n minus 1 degrees of freedom for the t value. All right, let's look at the sample sizes. So sample size, your margin of error with the sample size is going to say something like within 3 percentage points. And if it has a supplemental survey, it's going to be a percent. There's a supplemental survey somewhere there. It's going to be a percent. But real important is this, that it's going to say something like within 3% or 4 percentage points or whatever. And that's going to be the p hat times 1 minus p hat. Come on. My n is going to be p, seriously, p times 1 minus p times, and I forgot, what is it? Z sub alpha divided by 2 over e squared. Takes me a second to remember these things. And then for today, your margin of error is going to be like in miles per gallon or whatever the units are. Your margin of error is going to have units. ME has units. And the word mean is going to be in there. Somewhere, the word mean will be in there. And then this one looks like this. Squared. Hopefully those two screens are helpful so that maybe when you're, it's not so difficult in the homework because they split 9.1 and 9.2 up. They split those two things into two different sections. But once you're in the test, once you take the test, it's not going to be split up into sections. So these might be a couple of good screens to tab in your notes if you're one who does like puts tabs on it or whatever. These would be good pages um, to keep handy. Okay, questions before we move on to the lab. The lab's going to take all of 3.8 minutes. Any questions with the lab or before the lab? All right, I'm going to put my iPad down. We're going to pop over to the lab. Okay, for the lab, you're going to use your continuous data from lab 1 or any continuous data, really. I'm not super picky on what your continuous data is. So lab 1 is fine if you want to go back and grab that. And we're going to be using the descriptive statistics tool again. It should still be, if you're in your data tab, the data analysis thing should still be there. Unless you turned it off, it'll still be there because we're going to be using that. So I'm going to actually click on the data analysis and go down. Go up, I guess. I need descriptive statistics. We're going to do something a little bit different with our descriptive statistics. My input range, same thing. Highlight all of my data. Okay. So I highlighted all of my data. My output range, same thing. I want my output range to be in these boxes over here. So a couple of different things I want. I want the summary statistics. We did that before, but I also want confidence level for mean. So I'm going to click on that box. You can choose whatever confidence level you want. It defaults to 95%. But if you want to create a 99% confidence interval, go for it. If you want to do an 80%, go for it. Whatever you want your confidence level to be, you can change that and make it whatever you want it to be. It defaults to 95. If you want to do 95, you go for it. Just whatever you choose. And I'm going to click OK, and it's going to populate it over here. I'm going to make it bigger. Okay, so this all looks the same as when we did this before, but something different is here now. says confidence level. I'm going to make it a little bit bigger so we can read it. Confidence level 95%. This is your margin of error. This box next to confidence level, that's the margin of error right there. So I'm going to go over here, and this box right here is where we're going to do our Excel calculations. So I'm going to click in here, and I want this to be my margin of error equals, I want this box, enter. It's going to fill in that box for me. My mean equals the mean right over here. Hit enter. Beautiful. So now we're going to find the upper bound and the lower bound of our confidence interval. So the confidence interval, the lower bound is going to be my mean minus the margin of error. So I'll do equals this value minus this value and hit enter. My upper bound right here is going to be equals this value plus this value. Enter. So now I have the upper and lower bound of my confidence interval. So what's happening down here and you're interpreting your results is it's kind of scaffolding you. So what am I estimating? Because we're dealing with means, I am estimating the population mean. So don't just type in, I'm estimating the population mean. But you type in based on your data. I am estimating the population mean earthquake magnitude in the world. That's what I'm estimating. That you don't have to use your numbers yet. That's going to come later. So I want you to be specific. Make sure you're answering in the context of what your data is. Number two, how confident am I? I am 95% confident that the population mean is in my interval. That's all you got to write in there because my confidence level is 95%. I want you to be aware of what's happening. Down here is where you write your entire interpretation. So I would say, my population mean, I am 95% confident that the population mean magnitude of earthquakes in the world is between 6.86 and 7.23 on the Richter scale. So you're giving me everything, the entire interpretation in number three. And that's it. You're done. Questions? So I know I went through that quick. Sorry. Questions on the lab. There is also an instructional video. I think I don't know if it's better or worse than what I just did, but it's there too. Questions, comments, queries, concerns? All right, so any other types of questions while we're being recorded? All right. Oh, I do, before I get off the recording, notice that your assignments are all due a day later. I moved everything a day later because of the holiday. And Gwen has so kindly asked me to open the assignments early. Um, I don't know if I'll be able to get to them tomorrow, but probably, how about Saturday morning? That gives us one more day. I'm not going to send out the email, my normal Sunday email until Sunday, but I will open everything up. I'll open the final unit up tomorrow. So, or Saturday, sorry. Tomorrow's not Saturday. Tomorrow's Friday. I will open it up on Saturday morning. So that way get an extra day. And if you're enjoying Boatnik or just enjoying the lovely weekend, the long weekend, then you can have some extra time there. So I'll get everything opened up. So anything else for on the record? All right, I'm going to go off the record now.